Good evening, everyone. I hope my screen is visible. Yeah, good evening, good evening. Hello, everyone. Hello, hello. Yeah. I hope my screen and my audio both are clear. If there is any difficulty in hearing my voice or seeing my screen, then please write in the comment section. I will just look into it. So let's start today's session. So there is the third day on pandas, and let me just put on the earphones. Okay, so in machine learning, you will most likely use databases from many sources to train your learning algorithms. Pandas allows us to load databases of different formats into data frames. One of the most popular data formats used to store databases is CSV. Okay, so CSV stands for comma separated values and offers a simple format to store data. We can load CSV files into Panda data frame using the pd.read_CSV function. Fine. Now let's load Google stock data into a pandas data frame. The gwog.csv will be the name of our CSV file. Now what is being basically told here that there is a format of data known as CSV. What does CSV stand for? Comma separated values. It's nothing just but like, have you seen an Excel sheet, right? You have, I guess everybody has seen an Excel sheet. So in Excel sheet there are rows and columns, and just remove the grid structure, it will become a CSV file. So that is basically the easiest way of storing our tabular data. And generally it is a rule that we upload CSV files to our machine learning model for further processing. So the function through which we upload CSV is a built-in function of the Panda library, and that is .read_CSV function. Okay, so with the help of pd.read_CSV function, we upload the CSV files into our machine learning model. Clear? Now in this section we will be using a CSV file named gwog.csv, which contains the Google stock data. Stock data means, like, I guess everybody of you know what trading is. So in trading, like in the US stocks, the trading values of the Google company, so how much is going, like in which place it went down, in which place it went up. So everything that, like, the data will contain everything. So okay, so we are really going to study that. So as usual, in the first line we are importing the library. So import pandas as pd. Pd is the name of the variable which we will be using to alias the panda library. We now load Google stock data in a data frame. So Google_stock equal to pd.read_csv, and then within the bracket this entire thing. Okay, so what this is basically, so if we just try to see it here in the file section. So in the sample data, it will be in sample data there would be some CSV files. Okay, so here this Google stock data will also be there. So now we print some information about the Google stock. So print Google stock is of type of Google stock, and then print Google stock as shape Google_stock.shape. So this entire thing, this entire CSV file I'm converting into a data frame using pd.read_CSV. So what are the two functions of CSV read_CSV function? Number one, it helps us to upload the CSV file, and number two, it helps us to convert the CSV file into a Panda data frame. So the data frame name is Google_stock. Okay, so the Google_stock, we are printing the type and also the shape. So as you can see it here, it has of the type pandas.code.frame.dataframe. That means it's Panda data frame basically. And shape means like it's just printing the number of rows, 3313 rows and 7 columns, so quite a big data set. Okay, yeah, fine. uh, I hope everything is being clear now. If you are having any questions, you can about the content, you can ask me in the comment section. We see that we have loaded the stocks.csv file into a pandas data frame, and it consists of 3313 rows and 7 columns. Now let's look at the stock data. So I'm just looking at having a look at the stock data, and it's somewhat like this, that 0 to 3300 up to 12, and this date, open, high, low, close, ADJ, close, volume. Okay, so these are the columns and these are the rows. We see that it is quite a large dataset, and that pandas has automatically assigned numerical row indices to the data frame. Pandas also use the labels that appear in the data in the CSV file to assign the column labels. When dealing with large datasets like this one, it is often useful to take a look at the first few rows of the data instead of the whole dataset. Okay, so now we can take a look at the 5 rows of the data using the dot hit method. Now suppose here, if you are printing only Google underscore stock, it will be showing the entire data. But sometimes you don't have to look at the entire data. Like suppose if you are just wanting to have just a general idea about the data set, then it's enough if you just see the first 5 rows, right? Like it will just give us a basic general idea that we are wanting. So this Google underscore stock dot head, so I'm just printing the first 5 rows, and these are the 7 columns. Fine, everything clear up to this? Also, we just do this by dot head method, so this first 5 rows are basically printed out. If we want to print out the last 5 rows, then what we will do, dot tail. So the first 5 rows dot head, last 5 rows dot tail. Clear? Okay, everything is simple and clear up to now. So as you can see, these are the last 5 rows that starts from 3112 and it goes up to 3308. We can also use dot head n or dot tail n to display the first and last n rows of data respectively. Suppose we don't want to see the first 5 rows. Instead, we want to see the first 10 rows. So what we will do, we will write dot head in bracket 10. If we don't put anything in the bracket, by default it will take the value 5. But if we put something into the bracket, it will only print that number of rows. So let's do a quick check to see whether we have any NaN values in our dataset. Now I discussed about NaN values to a great detail in the yesterday session. I hope you have remembered all those things. NaN are the missing values. To check it, we have learned the functions of how to check it and also to count the number of missing values in a total dataset. And we have also seen that how to basically correct or replace or delete the missing values. To do this, so basically we will check whether there are any NaN values there or not, and we will use the dot isNull method followed by dot any method to check if whether any of the column contains NaN values or not. So date false, open false, so every column is giving the false value. That means there are no NaN values in the entire data set. I hope it's clear. We see that we have no NaN values. When dealing with large datasets, it is also useful to get the statistical information from them. Pandas provide the .describe method to get descriptive statistics on each column of the data frame. Now, .describe is a very important method because it gives the entire statistical information about the dataset that you want, everything that you can imagine. Count, mean, STD. STD means the standard deviation. Mean, 25 percentile. What will be the 25 percentile value? Like if you are within this value, then you are within the top 25%. In the 50 percentile value, 75 percentile value, or the maximum value. Okay, so everything that you want to know about the data set, like the statistical values that you want to know about the data set, you will get it here. And that is for each and every column, like all for all the columns it has been given, except if there are like except for the categorical columns, that is which contain strings or characters, like this type of columns, except those, and the date time columns, because in date time columns we cannot provide any such type of statistical measures because they aren't numbers, right? Like the date time is a different type of data type altogether. We will discuss about that later. So for open, high, low, close, and ATJ close and volume, these are only the 6 columns for which we can get the statistical data. If desired, we can apply the dot describe method on a single column as shown below. Suppose we don't want the statistical information for all of the columns. Instead, we want that only for a single column. So what we will do, we can also do that thing. So we will write the name of the data frame, the name of the like panda data frame. In third brackets, we will just mention the name of the column for which we want the statistical information. For in this case, we want the statistical information for ADJ close and dot describe. So Google stock ADJ close dot describe, it gives the statistical information, that is the count, mean, STD, standard deviation, mean 25 percentile, 50th percentile, and 75 percentile, and max for all the for the ADJ column. Okay, so it's giving only for one column. Fine. I hope everything is like visible and is clear to all of you. Like my screen is clear and everything is going just fine. Okay, for those who have joined late, hello to everyone, and yeah, let's continue. So similarly, you can also look at one statistic by using one of the many statistical functions pandas provide. Let us look at some of the example. Now here also, like for one column, we are getting too much statistical information like count, mean, standard deviation, mean, 25th percentile, and everything. If we want, suppose only the standard deviation for a particular column, then what should we do? Just we will write somewhat like this, that suppose we are, in this case we are wanting the maximum value of each column. So print maximum value of each column is google underscore stock dot max. It will be giving the maximum value for each of the column. Minimum close values, google stock close dot min. Average value of each column, google stock dot min. So for the entire data set, for any particular column, for like in if you're going in for any particular column, then any particular statistical measure, we can do anything that we want. Like we can just print anything. Okay, you will get it. Fine. So yeah, so these are all the printed that were there. Fine. Now another statistical measure is data correlation. So this is a very important thing that you need to understand. Data correlation, for example, can tell us if the data in different columns are correlated. Now what is correlation? Correlation is a statistical measure. For measuring correlation, there are different like metrics. One of the like most famous metric for measuring correlation is Pearson correlation coefficient. Okay, also shortly called as Pearson's coefficient. So Pearson's coefficient basically tells us that how data are correlated. By the term correlated, I mean that suppose if I give the statement that my data columns A and B are correlated, that means that the change like are highly correlated. If I say this, that A and B are highly correlated, then that means I can also say that any change in A will also bring a highly probable change in B. Like they two are similar behaving columns. If we try to increase or spike up the values of A, then the values of B will also spike up. Any change we do in A, such a similar type of change will also happen in B. And the similarity of them we measure it by correlation. Okay, like its effect on the entire model or its effect on the entire data like structure kind of thing. What is it's called correlation, the similarity in the effect between two columns. If the correlation is less, we will say that they are less correlated and they have less similarity. Sometimes correlation also goes to negative, like Pearson coefficient that I was talking about, so that ranges from -1 to +1. Negative correlation means that it is having opposite effect, that is a change in B is likely to bring an opposite change in A. Like suppose if I'm increasing the values of B, then the values of A will probably going to decrease, and vice versa. Okay, so that's the case basically. Any questions regarding the content that I'm telling right now? Okay. Okay. So I'm just displaying the correlation between the columns. So Google underscore stock.corr. So that's basically printing out the entire correlation chart. Now how to read this correlation chart? Now these are the name of the columns. These are the name of the columns. So open. So suppose my first column is open. Now it's a basic common sense that a column will be correlated to itself the most. Like they are basically the same column. So a column, if we try to find out the correlation coefficient with itself, it will be 1 because it's highly correlated. Like you are basically finding out the correlation of itself with itself only. So it's common sense that it will become 1. The correlation coefficient of open with high is 0.9999904. With low is this, with close is this, with adjective close is this, with volume is negative. That means that any change in positive change in open will bring a negative change in volume, and a positive change in volume will bring a negative change in open. Cool. So that's how you will read this entire chart. Any problem in this correlation chart? How is this correlation calculated? The correlation is calculated by using a complex formula. If you have like more interest in learning about correlation, you can just Google out about Pearson correlation coefficient. Okay, because Pearson, although there are many other metrics to measure correlation, but Pearson coefficient is the most famous and the most widely used one. So I would basically suggest that to use Pearson correlation coefficient and learn about the formula if you are interested, obviously. But that's not required basically. Okay. So a correlation value of 1 tells us that there is a high correlation, and a correlation of 0 tells us that the data isn't correlated at all. Now we will end this introduction to Pythons by to pandas by taking a look at the dot group by method. The group by method allows us to group data in different ways. Let's see how can group data to different types of information. For the next examples, we are going to load fake data about a fictitious company. Okay. So we were learning about this basically dot group by method. So data equal to pd dot read underscore csv. We are loading a csv file and then we're just printing the data. The data somewhat looks like this. And nothing to repeat this part because this part is the same as I taught in today's session at the beginning only. That is about the dot read underscore csv function. So this is the data that we are talking about right now about the fake company.csv. Now we see that the data contains information for the year 1980 to 1992. For each year we see name of the employees, the department they work for, their age and their annual salary. Now let's use the dot group by method to get this information. Let's calculate how much money the company spent in salaries each year. To do this, we will group the data by year using the dot group by method, and then we will add up the salary of the employees by using the dot sum method. Now group by method is nothing but a built-in function which basically makes your work easier. Suppose you have a big data set containing many rows and many columns, and so if you just try to find out things manually or if you try to do things on your own, you will be quite confused. So if you need just 2 to 3 columns, like at a time you are only working with 2 to 3 columns, so what you can do is you can just group by using those columns and just focus on that 2 to 3 columns for the time being. Okay, like for example, here we are doing data dot group by year and salary dot sum. So what it's doing is it's grouping the entire data by years. So what will be my groups? 1990, 1991 and 1992, because there are only three unique years in the year place. So there would be basically three groups, three unique years, and so three groups. So three groups are created, and the salary for all the employees in 1990, 1991, 1992 are displayed here. And the function and the entire statement for doing this is data dot group by year, that is group by year by the year column, then salary dot sum. Fine. So this is what this is happening. Can you give an example of where this might be used? See, I'm giving an example. I don't know whether you will be able to understand this or not, because ML has not been properly, like, if you know ML, you will be getting it. Like, suppose we have a lot of columns in our data set, and we really want to remove some unnecessary columns if we can, so that our machine learning process, like the ML process during the training process, it will take less time. So what we can do is basically take only, like, if we see that suppose two columns are highly correlated, we won't take the two columns entirely. We will take just one column and see how much accuracy it's giving. Because if two columns are highly correlated, both will have the same effect on the machine learning model. Then we can also take one column and see, and like we might experiment things. Okay, we can get good accuracy also, we cannot get good accuracy also. So yeah, these are the things that, like, where you can use correlation. There are also plenty of other things where you can use correlation. So we see that the company spent a total of $153,000 in 1990, in like 1990, $162,000 in 1991, and $174,000 in 1992. Now let's suppose that I want to know that what was the average salary for each year. In this case, we will put the data by using the dot group by, and just as we did before, we will use the dot mean. Instead of dot sum, we'll just do dot mean. So the average salary for 1990 is 51,000, 1982 is 51,000, 1992 is 58,000. Then name salary, D type, INT 64. Clear? We are grouping by the years, and there we are just finding out the sum of the mean depending upon what we want. Yeah, hello, hi for all those who have joined late. Hi. Fine. So we are just quite clear about this. Now let's see how much did each employee get paid in those 3 years. In this case, we'll group by name using the dot group by method, and just add up salary for each years. So year department 1990 admin. So what you're doing is, okay, let me just read it out. That year data dot group by year, comma department, salary dot sum. Like we are just grouping it by the years, like for which year how much they have got, then by the department, and then the salary, average salary. Like, sorry, not the average salary, the total sum of salary. This admin is getting 55,000, HR is getting 50,000, RT is getting 48,000 for 1990, for 1991, something like this, 1992, something like this. Okay, so yeah, that's it. Uh, okay, okay. Is my audio not clear? I think my audio. Yeah, I think it should be clear now. Okay. So yeah, basically we have also reached the end of the this entire thing, and yeah, that's it. So we see that in 1990, the admin department paid $55,000 in salaries, the HR department paid 50,000, and the RT department paid $48,000. While in 1982, the admin department paid $1,122,000 in salaries and the RD department paid 52,000. So you're getting it right. We can do grouping in one way, we can also do grouping in two ways. First case we did grouping only through the year, in the second case we are doing grouping by the year and department both. And yes, so that was it. So that was all about this panda group by function. Attendance link, we will provide it. Attendance link बनाते
मेरा नाम मत ले समझ जाएगा
okay. Okay, so okay, fine. Okay, if there is any background voice, sorry for that. Maybe for the last part there is some background voice. I'll just provide you the attendance link. You can just fill that up. You will get the attendance for today's session. Make sure that you have just attended every session till now, and you have also like filled up the attendance form for each of the day, and you will get your attendance timely. If you are having any questions regarding the content, you can obviously ask me, like regarding today's content or the previous day's content about NumPy, Pandas, or anything about the basic Python libraries, anything you want. You can just ask me. Just wait for a couple of minutes, you will get your attendance sheet. Okay.
Uh, हाँ हाँ बोलो। अभी तक तो कुछ मैसेज नहीं आया, लास्ट जब होगा तो कंप्लीट कर देंगे।
No, box plot I cannot explain it now because it is isn't in the topic. If you want, you can just like contact separately.
अरे ठीक है, बता रही हूँ, बिल्कुल बिल्कुल देखते हैं कब तक लास्ट।
Attendance link I am sending it right now. Please wait for 2 minutes. I'm just sending it right now. Just hold on the patience.
कौन हम देख के बता रहे थे, बता रहे थे ना उसे।
So I pinned the attendance link. Please fill up this form. You will get your attendance for today. And make sure you're filling up this properly because depending upon this you will get your attendance. And yeah, so nice to meet with you all of you. If you're having any question, I will just wait for a couple of minutes and then I will just end this live stream for today. Link to collab notebooks. All the notebooks have been uploaded in GitHub and it has been provided to you from the day one. So if you're not attending from the day one, you wouldn't have get the GitHub links.
एक्सपायरी वाला 24 तारीख को, 24/2/2022, 2 दिन बाद। ठीक, हाँ 24 को करना होगा।
Okay, so I'm ending this live stream. It was great to have a session with all of you. Thank you.
जब करो, yeah, bye.